Very good morning, students. So in this session first we'll know about what is the need of the protection system. So first we'll know about the need of the protection system. So first in the modern so we have the developing this thing. Okay, so rapid growth the modern power system. So due to that some of the equipment will need the protective and require the high degree of reliability. So we need the protective of the equipment not only for the reliability. Okay, so it will have to protect the equipment as long as their efficiency. So and should be have the economical way. So if wanted to protect the equipment for longer years should be in the economical, not for the over the cost. So that's one of the time. So first we'll know about the what is meant by definition of switchgear. So switchgear is maybe defined as a general term, so covering the wide group of equipment related with switching, controlling, protecting an electric circuit or equipment. Okay, so here we can write so the functions of the switchgear equipment. So we can as in for purpose operation. So if you see the two types, that is a one for the general operation purpose and another for, so here we can, so one is for normal. Okay, so we can take, so one is for the normal operation. Classification of the switchgear. So here the classification based upon the location. So switchgears are classified indoor, general up to the 36 kVA, and outdoor, that's it, greater than the 36 kVA. Okay, so classification based upon the working voltage they are classified as low voltage switchgear, that is up to 3.6 kV, and medium switch voltage switchgear, that is 3.6 to 12 kV, high voltage switchgear, that is beyond 12 kV. So in the low voltage, that is in our home domestic, like there the LV side 11 kV, that's okay. So medium voltage also carried. Next, medium voltage switchgear, that which has been developed from medium voltage. Okay, so from 3.6 to 12 kV. So this is one type of the switchgear equipment you can see in the tail. Okay, so next components and for the switching and interruption. So that's we can say that is the switches, air brakes, knife switches, we already swing and switching fuse combinations and circuit breaker and HRC fuse. So these are uh, relays, isolators, earthing switches, instrument transformer, so potential transformers there. Okay, so there is another part, and in this so different types of switchgear, so isolators, air brake switches, knife switches. So we are having the isolators are different, air brake switches, okay, knife switches also different. So equipments base, okay, so switches are applications for it also, the it will be differ, and the circuit breakers are there for large applications kV. Very good morning, students. So in this session we are going to learn about the isolator. So isolator, and then we go for the circuit breaker. So this is Mandra Krishna. Welcome to the class. So it may, this is the one. Okay, so this is the isolator. So you can see the here this isolator. So mounting insulation there and conductor input side and output side you can see. So blade. Okay, so it will be turned. Okay, so here simply it is called as a disconnecting switch, okay, which do not operate under load condition. So if load conditions is turned on, okay, so spark will be, there is arc formation will be, so make the huge damage. Okay, so do not specify under breaking and making capacitors. And here, so if isolators are carefully open, so supporting insulators started and cause the access to the operation. So that is it. It will damage the equipment when it will open the under load condition. Okay, should be open at the no load conditions only. So here coming to the AB switch, that's the air brake switch. So if you operate under low current, that is a no low current. Okay, so used for break the under light load conditions and used for the manually operate. Okay, it's not automatically. So function only when circuit breaker makes the circuit dead in the HV system. This is one type of the switch, and the air breaks. So there another switches circuit breaker. So there's the air blast. So do not confuse that. So air break switch is different, air blast is different. Okay, so this is the one type, so which will be mounted at the top of the line. Okay, so you can see uh, arcing horns. You can see the arcing horns will be remove the arc in between the lines. Okay, whenever the switch is opened, so this blade, so this and this will see considerably a symbol. So arcing horn, so this will be remove the arc in between the line, so when it's disconnecting the lines. Okay, so this is the air switch. You can see so contacts is whenever the contacts is open, so if load conditions, if wants high amount of arc will be produced here. Okay, so this arc is the causes the damage condition. Okay, so that's why should open and no load condition, there's a no current. And come to the knife switches, so it's we are seeing in the lab sessions also, that is a knife switches, low voltage applications, like making circuit and break the circuit. Okay, and operate from pivot, you can know pivot, and the having the double pole single throw, triple pole single throw switches also there, and single, that is called as a knife. Okay, so here simply it is called as a disconnecting switch. Okay, which do not operate under load condition. So if load condition is turned on, okay, so spark will be, there is arc formation will be there, so make the huge damage. Okay, so do not specify under breaking and making capacitors. And so classification of the isolator based upon the number of poles, that is a single pole, double pole, triple pole. Okay, so based upon the number of breaks, if we take the current interruption, so it will be single break isolator and double breaker. So it will having based upon the load condition. Okay, so here this isolator will hang the both sides are double side. Okay, so that's the in this case. Okay, so single break a type is known as a center break. So each pole comprises the two insulator track from the port. So simply it we can say this single pole will having the one link, so it will like this, so it will be rounded when the switch is there. Okay, so this is a single pole isolator. Okay, so start in the 90 breaks, rotate the 90 degrees, will be in the form of the break. So now coming to the double break isolator. So double break tells having the, you are seeing the isolator switch in the previous. Okay, so that is the one time. So here also known as a center rotating isolator. So they have the three stacks per pole. Okay, see, and two are fixed at the one at the center is rotating type. So in the center insulator stack can be swing about the vertical axis through 90 degrees. So while opening, the center stacks through the 90 degrees and contact the shaft swing horizontal swing the break. So you can see. And uses of the isolator, so isolating circuit under no load conditions, so breaking the charging under transmission lines, and they could use for the long with circuit breaker. Okay, so but there's a deviation but along with the circuit breaker, so it should be operated under no load condition. Okay, so circuit breaker is a load conditions, that's the fault conditions, and manually for under load conditions, that's a different part. And so here next is on the supply side of the circuit breaker. So based upon the, so if any variations are making of the maintenance purpose, then only we can use the circuit breakers supply side. Okay, and some there are the limitations of these isolators, so that is they cannot be open unless the circuit breaker is open. Okay, so if open, that is the total fault is occurred on the isolator only. Okay, should open and when circuit breaker is open, that's a triptych circuit, then only should we have to open the circuit. So no breaking and making capacities as works under no load condition, should know that while making the isolator should B, there is no load conditions, first thing. And use of air brake switches, air brake switch light load conditions, the it will be used for no load conditions only, and designed to open close the circuit under load conditions. Okay, that's a different, right? So isolator for the no load. Okay, so this is for the under load condition. Okay, so if then possibilities and limitation, the lamps or knife switches are used for the break the circuit light load conditions and cannot open automatically like a circuit breaker under fault. So this is like a switches. Okay, so it will not work as a switch, so make the circuit, break the circuit. So but should be careful while operating the under load condition, so it should be damaged if fault conditions, if continuously open, so that is make the another huge damage. So how in the, now coming to the part, that is the introduction to the arc formation, how arc form is in the circuit breaker or the isolator switch, or we can say in the any breaking switch. Okay, so what is the matter in the plasma? So here how the plasma, so we can say the how is the arc is formed. So we can say that the arc formation. Okay, so how, what is the main result of the arc production? So in these two, if the two contacts are placed away from the so here the arc formed, right? So how the arc is formed in between lines. Okay, that's the, yeah. So normal the molecules in the atoms are electrical neutral, but so when we charge, okay, so this, okay, so this to this here or surrounded air can be ionized. So due to the ionization process, so surrounding air can be, so when does ionization of the any medium occur? So what will happen, the ionization occurs, it will act as a path, so it will increases the temperature and collision of particular occur, and that the thermal emission from the surface of the contact, so this will damage the carbon formation on the insulator. So secondary emissions of the contacts, so field emission at the contact, so these all the balls will damage the equipment while operating conditions. So here the ionization leads to electric arc, so this gas conduct the medium, and when the circuit breaker open, breaker contacts in the arc, so stuck between the two contacts, so this will be if here the fault conditions also, if you open the circuit, so the two contacts continuously, the fault current will be flows. Okay, so here definition of the arc, so it is a self-sustained discharge of electricity between the electrodes of or gas or vapor. Okay, so here is a self-sustained discharge of electricity between the electrodes and gas or vapor. So if you take the electrodes, two electrodes, okay, so sustained discharge of the gas, okay, so electricity, so this is called as the arc. So during the arc discharge, the voltage across the electrode is, and here, so what is meant by arc voltage and arc current? So the arc voltage means the voltage that appears across the contacts when the arc is formed between them. Okay, now coming to the arc current, the current that appears across the contact when arc is formed between them. Okay, that's the difference. So arc voltage and the arc current. So so if the center insulator stack can be swing about the vertical axis through 90 degrees. So while opening the center, so effects of arc, so rise in temperature, failure of installation, damage equipment, so this will all over this arc, so it will cause the temperature rise in, failure of installation, damage the equipment.